Welcome to the DEFCAM. The successful orbital insertion of the PRSS HS-1, Pakistan's indigenously conceived hyperspectral Earth observation satellite, marks a transformative moment in the nation's strategic and scientific trajectory. This achievement, facilitated through a launch from Chinese territory, represents far more than a simple incremental upgrade in remote sensing capability. It signifies a fundamental paradigm shift in how Pakistan perceives, manages, and secures its national territory and resources. Unlike the multispectral satellites of the previous era, which could only perceive the world in a handful of broad color bands, the hyperspectral sensor aboard PRSS HS-1 operates on an entirely different principle of physics. It dissects reflected light from the Earth's surface into hundreds of finely sliced, contiguous spectral bands, effectively assigning a unique spectral signature or fingerprint to every single pixel within its field of view. This granularity of data is the core of its revolutionary potential. Every material on Earth, be it a specific mineral in a rock formation, a strain of crop in a field, or a pollutant in a water body, absorbs and reflects light in a characteristic pattern. Where a conventional satellite might simply see green vegetation, a hyperspectral sensor can identify the precise plant species, assess its chlorophyll content, detect nutrient deficiencies, and even identify the early onset of disease before any visible symptoms manifest to the human eye or a lesser instrument. This move from mere imaging to true material identification and compositional analysis elevates remote sensing from a cartographic tool to a diagnostic instrument of immense power. The applications for a nation like Pakistan, with its diverse and often stressed ecosystems and resource bases, are profound and immediately consequential. In the critical domain of agriculture, which forms the backbone of the national economy, the PRSS HS-1 provides an unprecedented tool for precision farming on a macro scale. It can monitor the health of vast tracts of wheat, cotton, and rice, providing data on water stress with a precision that allows for optimized irrigation, thereby conserving scarce water resources. It can map soil salinity incursions in real time, enabling targeted reclamation efforts before fertile land is lost. It can differentiate between crop types and assess yield predictions with remarkable accuracy, allowing for better national food security planning and more stable commodity markets. This is not merely about improving productivity. It is about instituting a regime of scientific management over the very land that sustains the population. In the realm of water security, another existential challenge, the satellite's capabilities are equally transformative. Pakistan's reliance on the Indus River system makes the monitoring of its headwaters in the Himalayan glaciers a matter of national imperative. Hyperspectral imaging can track glacial melt rates, monitor the formation and potential outburst risks of glacial lakes, and assess snowpack density with a new level of accuracy. This data is crucial for long-term water resource modeling and flood forecasting. Furthermore, the satellite can detect subtle changes in water quality in reservoirs, rivers, and coastal waters, identifying algal blooms, industrial effluent plumes, and sedimentation patterns that are invisible to other satellites. This allows for proactive environmental protection and the safeguarding of drinking water sources. For mineral and hydrocarbon exploration, the PRSS HS-1 acts as a powerful prospecting tool, reducing the time, cost, and risk associated with discovering new resource deposits. The unique spectral fingerprints of mineralogies such as copper, gold, limestone, and coal can be identified from orbit, allowing geologists to pinpoint promising areas for ground-based surveys. This capability can unlock significant economic value, reduce import dependencies, and spur industrial development by providing a clear, data-driven roadmap for the nation's extractive industries. It empowers Pakistan to conduct a comprehensive inventory of its own subterranean wealth with a clarity never before possible. Beyond these vital civilian and economic applications, the strategic and defense implications of possessing an indigenous hyperspectral capability cannot be overstated. In the modern security environment, information superiority is a decisive advantage. The ability to conduct detailed terrain analysis, identifying tracks, camouflage positions, and even the composition of materials used in construction provides a significant tactical edge. Hyperspectral data can reveal disturbances in the soil, the presence of certain manufactured materials, and other subtle signs of activity that are meticulously hidden from conventional reconnaissance. This enhances situational awareness along Pakistan's borders, contributing to a more robust and informed national defense posture. It represents a move towards greater self-reliance in the high-tech domain of intelligence, surveillance, and reconnaissance, reducing dependency on external sources of data and ensuring decision-makers have access to the most accurate and timely information. The development and successful deployment of the PRSS HS-1 by Saparco also signify a critical milestone in Pakistan's journey toward technological sovereignty. It demonstrates a mature capacity in systems engineering, data processing, and the complex algorithmic interpretation of sophisticated sensor outputs. The task does not end with the launch, it begins with it. The torrent of raw data downlinked from the satellite must be calibrated, processed, and translated into actionable intelligence. This requires a robust ground segment and a cadre of highly skilled scientists and analysts capable of wresting meaning from the complex datasets. The investment in this human capital is as important as the investment in the hardware now orbiting the planet. It cultivates a domestic ecosystem of innovation and expertise that will pay dividends across multiple sectors for decades to come. Looking forward, the data from PRSS HS-1 will serve as a foundational layer for a more digitally integrated and resilient Pakistan. It will feed into geographic information systems for urban planning and disaster management, inform climate change adaptation strategies, and provide an unbiased, empirical basis for policymaking at the highest levels of government. This satellite is a testament to a forward-looking vision, one that recognizes that the challenges of the 21st century, from food and water scarcity to climate volatility and strategic competition, require a response grounded in advanced science and technology. The PRSS HS-1 is not merely an eye in the sky. It is a sophisticated analytical brain, a national asset that empowers Pakistan to steward its resources with wisdom, secure its borders with confidence, and chart its future with the clarity that only such precise and comprehensive knowledge can provide. Thanks, and stay tuned for the upcoming videos.